Okay, so we are going to have this process of thermal energy transfer. We are having three modes of energy transfer. If you remember, we are done with conduction, is it? In the previous lesson, I will just give you a quick overview for the process of heat transfer with conduction. Then today we will discuss about convection and radiation, and inshallah it would be done for thermal. Okay, so for conduction, thermal energy is the total energy. This was all about the thermal energy. I have given you the idea. Sorry, just have a review, then it would be then. The thermal energy was the total kinetic energy of the atoms or molecules in the body. We have gone through that one. And that energy transferred from higher temperature to the lower temperature. This is basically the thermal exchange procedure I told you, that when the bodies would be in thermal equilibrium, sorry, when the bodies will be in thermal contact, they will exchange the heat. And then amount of thermal energy transferred is amount of heat flowed from hot body to the cold body. That was also explained. And thermal energy is transferred in three different modes, and those modes were conduction, convection, and radiation. Right. So let's talk about conduction in quick review. Right. So conduction is basically describe in molecular terms how heat transfer occur in solids. So the answer is conduction. But when we talk about conduction, the conduction is that heat process or thermal energy process in which uh, the atoms of the particles vibrate, and the electrons move from higher energy concentration to the lower energy concentration, from hot body to cold body. So this is what it is, simple mechanism of energy transfer in solids, right? So here, this was the molecular view. That area where the molecules are hot enough, their molecules have vigorous vibration. And if you zoom it in, here I have shown that molecule have more vibration. And here there is very small vibration. So due to that vibration, the molecules interact with each other. And this is what it is, simple mechanism of energy transfer in solids. So am I audible to all of you? Hassan?
सर अब
Yeah,
आ रही
here.
है, बीच में नहीं आ रही
हाँ,
थी।
ओके। अब आवाज आ रही है? अब देखो, अब सही आ रही है।
जी अब सही है,
Hmm?
अब सही है।
Okay, yes. So, Yaya and Ariba. Okay, okay. So, is it clear now?
Yes.
I was saying molecules are moving from hot body to the cold body. Basically, what happens when the molecules are getting heated? The molecules gain energy and vibrate faster, and these molecules collide with their less energetic molecules or neighbors, and that's why that energy is transferred, right? So, these neighboring molecules, which in turn gain kinetic energy, then they collide with the next neighboring molecules, their vibration increases, and so on. This process is continuous from until the cold end reaches to the same temperature at the hot end. I told you that this is called your thermal equilibrium. What did we call it? That thermal equilibrium, when the molecules will be no energy transfer at all. So this is the basic concept of any conduction in any metal. Now there is another game inside. Basically, there are some nightmares which are transferring the energy at the rapid pace. Check these one out. So when you are going to heat up a metal, what happens? Basically, these atoms liberate electrons. These are the electrons of your uh, you know hot atoms, right? So when these are the electrons of hot atoms, Actually, those electrons are free to move.
सर स्क्रीन शेयर नहीं हो रही.
They have very rapid motion. That's why they reach to these colder areas before the energy is transferred due to vibration. That's why the conduction is faster in metals. Okay? The conduction in the thermal energy in the metal is so
सर
metal is far. Yes.
सर आपकी स्क्रीन नहीं शेयर हो रही.
Oh, sorry. When it happened? अभी अभी हुआ है.
जी सर थोड़ी देर पहले.
ओह सॉरी, मुझे टाइमली बस बता दिया करो. बेसिकली व्हेन इंटरनेट स्विचेस तो उसमें थोड़ा सा मसला होता है. नाउ इज इट शेयर्ड?
यस सर.
ओके. सो मैं ये कह रहा था कि व्हेन कंडक्शन ऑफ द थर्मल एनर्जी in metals is far better than that of the other solids. Why? I was saying that basically these electrons are responsible to transfer the energy from hot end to the cold end this way. So they rush towards cold ends and they transfer the thermal energy. That's why metals are very good conductors as compared to that of the non-metals, right? So vibrating molecules is happening inside. लेकिन क्या है, molecules due to vibration energy transfer is very slow, but due to transfer of electron energy transfer is very rapid. So when heated, free electrons gain energy and move faster. That's why they are free to travel in the places between the molecules before colliding with the other electrons and molecules. Then they transfer some of the energy to them. So as I told you, this all is happening in only metals, right? So without, I mean, other than metals, it does not happen. So is this slide clear to all of you?
Yes.
यस सर.
Okay. Okay, good. Now, this process is much faster than the conduction by vibration of the molecules in the body. Hence, metals conduct heat much faster than that of. I have explained this all. Just you can go through that. What I have written in that I have stated. So, conduction cannot occur when there are no particles present. It means in vacuum. Yes, this is very important point. In vacuum, there is no conduction at all, right? Vacuum is a perfect insulator. That's why we use some evacuated glasses when there are some double glass windows. We evacuate or we produce vacuum in between them. So gases and liquids are poor heat conductors because their particles are far apart. So these lines are really really important. That's why I have changed their color for you. The state of color, I mean importance level
सर
tells. Yes.
सर तो फिर इट मींस के कंडक्शन में इट्स ओनली अबाउट मॉलिक्यूल्स राइट.
Yes, exactly. Because molecules will vibrate, right? And when there would be molecules, then definitely electrons would be liberated from there. So game starts from your molecule. If molecules would not be there, neither your interaction will take place with other molecules, nor your electrons would be free to travel from hot body to the hot region to the cold region. So molecules are mandatory for conduction. So if there is no molecule or if there are no molecules, conduction does not take place. So it means in vacuum, no molecules at all, so no conduction take place. So heat cannot travel through vacuum due to conduction, or heat cannot be conducted in vacuum. This is actually what I mean to say. So is this clear to all of you?
Yes.
Yes. Any other question? Any other question?
नो सर.
Okay. Now there are different examples in that. One of them is this is a hot tank, and it consists of four pipes or rods. All rods are of different materials. This is steel, this is iron, this is aluminum, this is copper. So they have different amount of sorry, they have same amount of wax attached with them. And here we have a boiling water placed inside. So this is the conduction tank. So what happens? The amount of wax available are still existing on the rods tells us that how good conductor that is. So for example, they all were filled with wax, complete wax was there. So steel is left with most of the wax on it, then iron, then aluminum, then copper. It means most of the wax has been removed from copper rod because of heat transfer. It has been melted. Somewhat is on aluminum, then on iron, and then in steel. So if I compare, then which one is good conductor? So mm, this is basically good conductor because it has molten most of the wax because it has transferred a lot of energy over here. So secondly, aluminum is good conductor, then iron, and then steel is. So steel has the fourth level of thermal conduction in metals, right? Because steel has some alloy of so steel is the combination of carbon and iron. That's why. And some other alloys are also there. But remember this thing, this is one experiment which tells that which metals are good conductor. So I think it's very obvious slide. So if you have any question, we can move on. Should I move to next?
Yeah.
Okay. So here some poor conductors and some good conductor list is there. Gold, good conductor, silver, copper, iron, brass, and then aluminum. These are the list. This is not the order. Remember this thing. Then glass, stone, water, plastic, wood, polystyrene, foam, wool, fiberglass. They all are non-conductors, poor conductors. That's why they are used as insulators. In my last slide, I mean, in my last lesson, I told you where do we use these insulators and where do we use these conductors. So, this was the list. So there are some past paper questions in the in coming upcoming slides. So if you are having some theory about this, for example, I will discuss few of the questions with you and then I will move to the convection, right? An iron bar is held with the one end of the fire, one end in the fire, the other end soon becomes too hot to hold. How was the heat traveled along the iron bar? So yes, Ariba.
Conduction.
First, it's okay. Conduction, good. Hassanul Abdin, आपने आंसर किया ना? You are genius boy. Very good. So, Ariba, are you agreed? Welcome.
Yes, sir.
And yeah,
Yes.
you agreed too. Very good. Yeah, Hassan, everyone is agreed with you. Okay, now here, this diagram tells you the same experiment what we have performed. The heat is transferred to all of these rods. They have attached wax and some sort of balls with one, two, three, four balls are attached with all of the rods before hitting, and then when you hit it up, A is left with one, B is left with three, C is left with two, and D is left with four. So which labeled metal is the best conductor of heat? Yeah.
Um, A.
A. Ariba.
I also think A.
Is it a locked answer or tukka?
I would like to say locked.
Okay,
I'm a
good.
bit unsure, but I think I'm locked on this.
Okay, or Hassan, what's your choice?
A.
A. Good. So if I ask some explanation from you, so will you people will be able to explain it? Yes. Yes, A is the right answer. Well, so explanation is that metal which is good conductor, it transfers a lot of heat or it transfers more heat. That's why most of the wax is melted and these balls are dropped. That's the reason only. Okay. The next one, yes, this is very
Sir, can you explain the reason again?
yes. That metal which is good conductor, it transfers the heat at higher rate. Okay, that's why it is able to, the wax on that metal is melted. Due to melting of the wax, what happens? These balls are dropped, they are no more attached with that na. That's why. So जैसे जैसे wax melt होगा, so what will happen to the balls? They would no more attach with the rod, so that's why they would start dropping, they would start falling down. So that metal in which wax is still solid, the balls are attached. Here the wax has been melted till this point because it is good conductor as compared to this, because heat is not yet reached to this level, heat is reached to second ball. Here heat is reached to third ball, so it is mm, good conductor but not as ball 1. So in metal A, wax is reached to the level of ball 1. So heat is transferred from this end to this end. Here heat is transferred from this end to this end. Here heat is transferred from this end to this end and this end. So in which heat is transferred for more distance or longer than length? A. Is it?
A.
So that's why it is good conductor. That's why heat reached to this point. Na?
Yes, sir, clear.
Yeah. Any question?
No.
Okay. So next one is, a rod is made up of copper and wood joined together. After the rod is heated, at the join in the center for about a minute. Okay. After the rod is heated, at the join here where this is having this copper and wood together. Okay, where would the lowest temperature being observed, or where would be the lowest temperature? This is the point where you are supplying the heat. So because answer is obvious to you, that's why I can explain it to you. Because wood will not transfer the heat over here, so it would be the smallest temperature. The highest temperature will be over here. Okay, second highest temperature will be over here, third highest temperature will be over here, and fourth will be, I mean, in decreasing order, first, second, third, and fourth. So fourth level has the least temperature, then third, then second, and then first. Is it clear to all of you?
Yes.
Okay. Hassan and Ariba, is it clear to you as well?
Yes, sir.
Yes, sir.
Okay. Okay, good. So that was basically some idea about convection. Now let's talk about convection. Actually, convection is a sort of uh, bigger concept than convection. Convection is that process in which molecules move from one point to another point practically, right? I mean physically, not practically, sorry, physically move from one point to another. Let's say, if I give you an example of conduction, uh, I have given you the example before. This is the table where you are going to have your lunch or dinner. If person one is taking some food, then he is going to transfer the food to person two, then three, then four, and then so on. This is person number eight who is receiving it. But if there is a setup in which food is placed over here, this is your food. Okay, these are the people. Okay, and sorry, in this way. In this way, this is 1 2 3 4 5 and 6. So if one is taking food from here and he moves to the table, then it is the turn of second, then he takes the food and turns to the table, third, fourth, fifth, sixth, and seventh. So what is this? This is basically motion of the particles towards the energy source, taking energy from the energy source and moving away. Are you getting this thing?
Yeah.
This is very, gentle example of convection that normally in these dinners and functions in hotels, we have this type of mechanism. The food is the source of energy. Everyone has to move to that source, take that energy from there, and then move away from the source. So let's relate that over with our convection mechanism. So liquids and gases are poor thermal conductors. I have explained this why, because their molecules are far apart. But their particles move all the time. That is the reason. The particles do not vibrate. So conduction has a limitation. Conduction will only take place when vibration will be there and free electron diffusion will be there. When a liquid or gas is heated, energy is transferred to the particles, causing them causing them to move faster and further apart. Is this very clear to all of you? When you take the food, before taking food, everyone is very closer to each other in a line or in a queue, right? When you take that energy or when you receive that, someone will sit on that table, someone will sit on that table, and so on. So this is basically the same thing happening over there, that the molecules which are taking energy, they move here and there. They basically move away from the source of that energy and move further apart. So convection is the process by which, this is the definition, you have to recall that convection is the process of the thermal energy transfer from one place to another by movement of heated particles of the gas and liquids. Right? So, what you have to define or what you have to remember for definition, the process in which thermal energy is being transferred from one place to another by movement of heated particles. This is the key point over here. How do the thermal energy transfers? By the movement of heated particles. Is it?
Yes.
Is this clear to all of you?
Yes, sir. Yes.
Okay. Now, if I say that which type of experiment or example do we have for our convection? So, is this example clear to you people? If you see that the liquid molecules are there, they are over here. When they are getting heat from the source, they are moving apart. They are moving. Actually, they are moving upward. They are floating upward, right? They are floating upward this way, right? So here I have explained it. So when the liquid particles are heated, they expand, right? Heat, actually not molecules, the liquid expands. Due to that, it becomes less denser and it floats, because as I told you that those molecules which have lower density, they move up, and those molecules which are cold molecules, actually cold molecules are those molecules which are having low density till now, they are uh, closer to each other. It means their density is more, so they move down, they sink. Okay. And those molecules which are receiving energy, they move apart and they move upward. So hot molecules get energy and they move up, and cold molecules move down. So in this way, you know what happens? A bulk movement of particles is started. The cold and denser molecules move down, they replace it. This in turn gets heated up. I mean, when these cold would reach to the heat source, I mean, those people who were at the end of the line, when they will reach to the food table, what will they get? They will get the food from there and then they move about. The circulation of the liquid in this demonstration is called convection current. What do we call this all movement? This is called your convection current. Is this all clear? Hmm?
It's good.
Okay. Ariba, is it clear?
Yes, sir.
Yes, sir.
Okay, good. अब आपके पास convection current experiment है. So convection in gases is basically demonstrated by this experiment. What do? We have some glass, sorry, we have a box, right? And in that box, we put a lighted candle. We can just use it for a heat source. This is the heating source over here. And you inject or you pump in some smoke inside this tube glass cylinder, right? Why I use this word pump in? Because when the smoke will be cold enough, when you will place it, it would sink down. And when the smoke is sinking down, this would be accommodated over here in the box will be filled with smoke. This is the end where you are going to heat it up. When you are going to heat it up, all the smoke particles will be moving upward here. They would be moving upward because this is not a closed path. That's why smoke is not getting back to this tube. So this is that experiment which tells us, or which basically explains us that how the particles move while convection takes place. So convection occurs much more readily in gases than liquids. Why? Because gas particles are very apart from each other, and those gas particles uh, are free to move as well. That's why the convection is very clear or obvious in gas particles, right? Rather than the liquids. For in liquid, uh, convection occurs over there, but that is not that much significant. Okay, but that is significant in gases. So you have to remember that gas particles have a significant convection, right? Is this clear? Because they expand much more and they're than the liquids. That's why, sorry, when their temperature is raised, then they have scale squared of the. Okay, is it clear to all of you?
Yes.
Okay, अब आते हैं इस पे. This is the first question from your convection. An experiment is carried out. This is a past paper question. All the questions which are basically in this presentation or in this slide or in this document, they all are from your past paper. And an experiment is carried out as shown in diagram. ठीक है जी? This is the diagram. Diagram explain कर लेता हूँ मैं. The steam is there. You are going to heat it up from the burner. Some boiling water is there at till this level. Then glass tube is inside. Then we have a wire gauze. We have basically fixed some ice below this. तो मुझे ये बताइए कि if this is ice, why the ice is not melting although it is placed in the hot boiling water? Yes, Hassan will tell me first. Yes, Hassan. आप लोगों को आवाज आ रही है?
जी जी सर आ रही है.
अच्छा अच्छा, सोच रहे हो तुम. सॉरी मैन, मैं क्वेश्चन भी दिखा देता हूँ. Okay, this is the question. Yeah, this is the question. So why does the ice take long time to melt even though the water at the top of the tube is boiling? Everyone has to answer this because answer is not revealed to you. So please, all of you have to think about that.
Sir C.
Yes. Yahya, are you agreed?
What?
Are you agreed with this question? I mean, are you agreed with this option? C?
Yeah, kinda. Yes.
A kind of. In
Yeah.
MCQs, there is not a kind of agreement.
Okay.
Either
C.
you have to see. Okay. And yes, Ariba, you have to decide because now both of them are agreed at C. So are you going to give them a favor, or you are going to have any other option?
I also thought it was C. It seems like the only
Wow.
reasonable answer.
Oh my God. You are going to follow majority's authority, right?
I genuinely thought that from the beginning, but I
Yeah.
suppose in this case it looks like it. So yeah.
Actually, this is, this is a democratic strategy, but it is not a physics strategy. All of you are failed. Got it?
Oh,
Sir,
Okay, why this ice is not melting? Because it is placed, although it is placed in the hot and boiling water. This is that
sir,
question. Yes.
is it B?
Water is a poor conductor. Yes, it is D. Yes.
oh wait, it is
Listen.
metals. Yeah, metal. Metal is
Rem- yeah, it is actually, listen, when you are going to heat up this water, the hot water will not sink down, it will move up. Okay, it will move up. So hot water will move up. So when you are going to talk about melting, for melting of ice you need hot water, but cold water sinks down. Whatever the water will be cold, it will sink down. So wire gauze is only placed. What is the reason of wire gauze, Ariba, over here? Because you have discarded your option C. That's why I'm asking to you. Why did we place this over here? Yes. MCQ is an MCQ. You can be asked any question.
Sir, I
Oh,
would
Mirab.
like reasonable, but just to make our lives harder.
Oh
Just
my God.
separate it or something.
Yes.
the ice doesn't float up.
Yes, exactly. Because ice is ice has less density or smaller density. What mean less denser than water. So if you will not place wire gauze over here, it will float up. Yes, that is the reason. Mirab,
Yes, sir.
यार इतनी देर होगी तुमने मुझे बताया नहीं कि you are also in the class. I'm searching that where is Mirab. That's why I'm asking the questions from these three. My God. बच गई हो तुम बाल बाल. तुमने अब तक एक क्वेश्चन का आंसर भी नहीं किया.
नहीं सर, मैं इधर ही थी तब से.
Okay. So you got this all? What
जी
you were
सर.
discussing?
जी जी.
Okay, good. So are you people clear in this discussion? That what is the role of convection and what is the role of density? Should I
Yes.
move to next slide?
Yes, sir.
So these type of questions are basically the horrible questions for you people. Oh yes, answer should not be revealed over here. That's why I don't know why I put answers over there. Okay, let's explain. Meetup, explain why answer is C. चलो अब आपसे पूछ लेते हैं.
सर मुझे एक क्वेश्चन पढ़ने दें.
पढ़ो question. Everyone is supposed to read the question and then think about the answer. Okay. गूगल नहीं करना, ठीक है?
सर ये कंफ्यूजिंग सा है काफी.
यस, इसलिए तो एमसीक्यू है. यस, अरीबा, नेक्स्ट इज योर चॉइस. देन थर्ड इज फॉर याहिया एंड फोर्थ इज फॉर हसान. नंबर याद रख लो अपना अपना. Hurry up. One MCQ mean 1 minute, not more than 1 minute. पैसा प्यार, मैंने अभी रेडिएशन भी पढ़ाना है. Yes, next. I'm coming back after completion of cycle. Mirab and Ariba, जब तक सोचो.
Yeah, okay.
Okay, yeah. What's your choice? Where will you place the filament? Oh, sorry, a heating element.
It's C because the current can go both up and to the left. It can go from both.
Okay, good. Hassan, what's your idea? Why is that C? Why he's going to place this filament over here at
And
C?
also see it can like hot one goes up. So it's that's
Okay.
is better than A. Forgot to mention that.
Very good. So here is your heating filament. So when you are going to place heating filament over here, I mean over here at this corner, so you know what will happen? Yeah, sorry, Hassan. Yes, explain it to me. थोड़ा सा फर्क है. Just small. Yeah. Your answer is not 75% correct. Yeah, there is a 25% error in that. Hassan, you have to clear that. जल्दी करो शाबाश. Yahya told that hot molecules will move up. Yeah, I agreed. But there is another option that when hot molecules are moving up, they would transfer the heat like this, and then they would move down from here and they will reach to this point. See. Okay? So hot molecules only move up over here. Okay? This is the horizontal level, so they can move, they can float. When cold molecule will move this way, cold molecule will move from let's say from D to C, then space would be created downward. That's why this movement would cause. So overall there would be a convection current takes place in this way. Is it clear to all of you? This was another confusing question for you people. So oh yes, yeah, why I have put this
इसमें
D.
से
Hmm?
एक मिनट आप दोबारा से ये आंसर रिपीट करें.
हाँ ये वाला, बिकॉज मैं ये कह रहा हूँ कि बिकॉज हॉट मॉलिक्यूल विल मूव अपवर्ड. ठीक है, when the hot molecule will move upward, the cold molecule will move downward from here and they will reach to this, they will occupy this space which has been created over here. Due to that, an avalanche will start for the molecules. All of the molecules will sink down and all the molecule will move forward. Space would be created. That's why this type of current would be, or this type of movement would be created in this tube this way, an anti-clockwise movement. Okay? Is this clear to all of you? Okay. Now, what will be the answer for this one? जिसने देख लिया, he would be in the winning position. But you have to explain it. Now, I will have a reverse game. Hassan will tell first, then Yahya, then Ariba, then Mirab. Hurry up. Hassan, it can be B and D both, so don't get confused कि मैंने किसको damage किया. Now it is completely damaged.
नहीं सर है डी मगर वजह नहीं पता।
मगर क्यों है ये तो explain करना है. Yes, hurry up.
नहीं सर, इतना सिंपल सवाल करो, मुझे इतनी मुश्किल दे रहे हैं, इतने सवाल.
आप लोगों का एक भाई भी है, वो कह रहा है मुझे मुश्किल क्वेश्चन दे रहे हो. Yes. Okay, explain it, Hassan. Jaldi karo, shabash. Convection is the basic theme principle what we are going to discuss right now.
सर वार्म एयर इज डेंस, वो ऊपर होती है तो नीचे इतनी कांटेक्ट में नहीं आ रहा वो.
No. Warm air is, or hot air is not dense. It is less denser. So it will move up.
डेंसर तो वो ऊपर होती है.
ऊपर जाएगी. So hot air will be moving up. So you know what will happen? Temperature would be more over there. But cold air, what this ice make to the air? Ice makes the air colder or hotter? Yeah.
Colder.
Colder. So cold air would move up or down?
Down.
Cold down.
Down. Cold air will move down. So Ariba, what's your choice then?
Sir, my brain is questioning itself. I feel like it's B, honestly. I don't know why.
Okay, no problem. Listen, Ariba, be confident. Whatever you think, you have to display your answer, your card, right? Don't follow anyone, because you know when we are following each other, it's cheating. Right? Yes, Meerup, what's your choice?
Sir D.
D. Can you explain why D? Yeah, you are left.
Sir,
You have
because
to
you
decide.
mentioned that
Yes, yes.
the hot air will be above, so it's B. But there in the question it's saying that at which point is the temperature the lowest, and you said
Lowest.
downwards the temperature will decrease.
नहीं मैंने ये नहीं कहा. I don't take said this thing. I take my words back. I
No,
just
obviously,
told
I forgot.
that obviously yes. This was the meaning. Listen, now I'm going to explain it. Yeah. Will you? Are you agreed at D?
Yeah, I guess, yes.
Okay, very good. So this is that region where you have air to somehow. When you place ice over there, ice will make all the air cold. Cold, is it? Are you agreed?
Yes, sir.
Okay, so when the air on nearby the ice block will become colder, so what will happen? It would sink down. It means it will make the temperature down surrounding this all. Got it? So this would be the lowest and where all of the cold air will reach. So this would be basically your coldest point. D. Got it?
Yes.
Okay. Ariba, is it clear? Oh, yes. Please don't. Oh, yes, that is the question. I will not show you the options. Maybe options are on the other page. Please, just don't show me. Oh, very good. Great. Question check kariye. Thermometer X is held above the ice cube and thermometer Y is held at same distance below the ice cube. After several minutes, the reading on both the thermometers changes. The ice cube does not melt. These all are the conditions. Is this slide clear? I'm going to move. This is the information slide. I will move to the question slide. Is this information clear?
Yes, sir.
Yes.
Okay. Should I move to the question slide?
Yes, sir.
Yes. अब बताइए. This is which thermometer reading changes and why?
ऊपर वाला एक थर्मामीटर था कि नीचे वाला?
X was at the top and Y was at the bottom.
ये शुरू कर.
Yes. Order is Mirab, Ariba, Yahya, Hassan.
Sir, एक मिनट से ऊपर scroll करो. I need to read the question.
नहीं scroll नहीं कर सकता. Question ये है कि there is an ice cube and there are two thermometers held at equal distance above and below. This is your thermometer X and this is your thermometer Y. So which thermometer will okay, the reading on the thermometer, any one of the thermometer has changed, and why? Reason.
So it's B.
Okay. Yes, Ariba.
I also think B.
Okay, 2 votes for B. Yes. Yahya. Yes, Yahya, it's your turn.
C.
C. And Hassan.
C.
C. Now match is in crucial condition. 2 plus 2. So who has to decide? Okay.
पांचवा बंदा है.
Yeah.
तो हो सकता है B हो.
Okay. Oh, good. B got 3 votes. Okay. Now let's decide who will explain from B voters. Meerab and Ariba. Who will explain both of anyone from both of you?
Yes. तो
Sir, because in the last question you mentioned that above the ice cube, warm air rises.
Okay, yes. So X, warm air rises. But what is the function of ice? To make
It
the
cools
air
down the
hot
air.
or cold?
Just
Ariba, you can
Cold.
support your partner in voting. Yes,
Alright.
Ariba and Mira both are at the same opinion, with the same opinion. So you both can help each other. Meanwhile, Yahya and Hassan, you have to create logic for your option C. Hurry up. Good, 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 good. Carry on.
Who answers?
Yes, Mirab and Ariba. Either convince both of them for option B or they would convince you for option C. It's up to you. I'm
I
referee.
could try, sir.
Yes, try it.
I'm quite sure the current happens because the heat begins to push the like heated particles upward. So that would make hot air rise upward as the cold air would just shift. The cold particles would just shift downwards within the ice cube. But that's just my thinking. So.
Okay, so Ariba, are you going to help your partner?
I seriously am trying. I'm still like trying to think of how to explain it.
No, no, no. Sorry, Mirab. Yes, you explained well. Mirab explained well. So both of you are trying to say the same thing, that hot air moves up and cold air moves down. Yes, it's your turn.
But
Y and
the
H.
air in this question is the ambient air anyway. It's actually air is not getting hotter. It's just some of it getting colder, and that colder one is going down. Rest of the air is same temperature.
Okay.
The one rising up is just same temperature. It can't gain energy from anyway. It's just ice. Where does it gain the energy from?
Okay. Hassan, what will you say?
Sir, when the air around the ice cube, when it touches or when it comes in contact with the ice, it becomes colder and it falls. So then the thermometer wise reading changes,
Changing, will it decrease or increase? My
decrease,
next question.
decrease.
Decrease. So are you people agreed, Mirab and Ariba? Are you people
Sir,
agreed with this logical reasoning?
No, I stick.
Yes, Hassan.
No,
You
sir.
wanna say something?
सर नीचे सी लिखा हुआ है सही है
Leave it na. C likha hua hai, D likha hua hai. Don't go through that. Just explain with your reason. Yes, definitely right option is C. Yes, I would reveal this one. Right option is C. But right option has to be right by your logic. ऐसे नहीं है मैंने लिख दिया, मैं भी गलत लिख सकता हूँ. But reason is, listen, every one of you tried your best. Well done. यही चीज मुझे चाहिए कि everyone should give some logical reasoning. Otherwise your concept will not be developed. कोई, it's not a beneficial tool के I have to deliver Jumatul Vida and Khutbah and move on. We have to discuss with open mics. This is the main, contribution in your skill. So this is ice. So what is the main function of ice? To cool down the air nearby. Is it? Got
Yeah.
it? Are you people getting it? So when air would be cooled down, definitely it would sink down. It will not move up. So this thermometer X would have has no effect. Okay. But because cold air is reaching to this thermometer, so its reading will decrease. So this is thermometer Y. So its reading decreases. Now I'm going to plan another question. At the same situation, you have two thermometers and you placed a heating coil in between them, right? What is that? We have a heating coil, heater, okay, or a hot block of iron, hot block of iron, okay. Same thermometer X, thermometer Y. Now this hot block would affect, or what will be the function of this hot block? It will make the nearby air molecules hot, not cold. Are you people get it? Anna, will it happen in this way?
Yes, sir.
Are you people agreed or not?
Sir,
So
could
when
you
it will
explain this?
make the nearby air hot, yes, I'm saying that if I have two thermometers, right, X and Y, and I have a block of, you know, hot iron. This is hot iron. I placed at equidistance. This is just hot iron. Okay, that is not ice, hot iron. So what is the function of hot iron? Iron block over here. What will this block do to your nearby air? Yes, yes, yes. Carry on. It will make the air particles hotter. Yes, it will. It will create warm air. Actually, yes, you are very right. It will create warm air nearby, but warm air will not sink down. It will move up. So when it will move up, it would affect the reading of this thermometer to be increased. So your Y will increase because the hot, sorry. Your X would increase because hot air rise up. Yeah, hot air rises. Is this clear to all of you?
Yes, sir.
This
Yes, sir.
was the most tricky question in convection. So yeah, again I have another one. मतलब ढेर सारे questions हैं which are debatable. A beaker contains water at room temperature. How could a convection current be set up in the water? Yes. Cool the water at X, cool the water at Y, stir the water at X, stir the water at Y. So first I will give chance to Ariba. Yes.
Sir, please just let me read it once.
Yeah, you can read it once, twice even. Shabash, carry on.
I think the answer is D.
D, stir the water at Y. Okay. Yes, next turn is for Yahya. A, cool the air at X. Okay. Yahya, and then Mirab. Mirab, are you there?
जी सर आपने उससे हसन से पूछा ना पहले.
नहीं, Yahya हो गया पुत्र, Yahya हो गया.
Okay.
Then Mirab and then Hassan.
Yeah, I
Then
think it's
end
B.
पे है. B, bravo.
No, D.
D, delta. Okay, yes, Hassan.
A.
A. अब देखो फिर वही काम हो गया. Both boys are locked at A and both girls are locked at B, D. So how can I decide? Again,
Sir,
tie condition.
पीछे कौन बैठा हुआ है? आपका बेटा है?
चलो,
और
it's
पूछ रहे
नहीं मेरा बेटा नहीं है वो. मैं एक A levels 2 के बच्चे को साथ बिठाया हुआ है. वो काम नहीं करता था. मैंने कहा बैठ के काम करोगे तुम. यस, वो तो आंसर कर लेगा. because he is in A levels too. इसलिए उससे मैं पूछ नहीं रहा हूँ. Okay. Yes. What's your choice? Now it's first turn. I offer to Hassan. Hassan, can you convince the D option students?
Sir, if you cool the water at X, the cold water is denser. It would come down, and the warm water, which is less denser, नहीं वो तो पहले से ऊपर है.
Yes, but it would create space over here.
And when
Isn't it? When water
Yes,
is
sir.
moving down, yes,
यहाँ स्पेस बन जाएगी जो नीचे से
the
पानी
warm
होगा
water
ऊपर
will
होगा
move.
तो एक करंट बन जाएगा.
Yes.
Yes.
Yes, exactly. So, Yaya, are you agreed?
Yeah.
Or you want to add something to your
Yes, he was
option-based
explaining A, right?
partner?
Yeah, yeah, correct.
Yeah, he
correct.
was explaining A exactly.
Yeah, I agree. I
Okay,
agree.
so Meera. Okay,
Yes,
good.
sir.
Meera, what's your choice?
Sir, D, because
Do you
I'm
do you
not
think
sure.
that you have to shift? Okay, okay. No, do you want to shift to A now
No, I don't want
or
to.
not?
No.
Oh, great. Very good, very good. Ariba, you're not alone, right? Well, शाबाश यार, आज तुम लोग बड़ी मजे की क्लास बना दिए तुम लोगों ने. Yes, continue. Hurry up.
I'm not sure, but I think
मैं
that
सर्दी
if
में
we stir the
मर रहा
water,
हूँ.
if we stir the water at Y, the current is gonna like go upwards probably, and so eventually the circulation liquid will be
Stirring mean you are going to mix the water, right? Okay,
Yes.
good. Stirring mean mixing. Okay. So, okay. Yes, Ariba, do you want to add something to your comments?
I don't think so. Her thinking is my thinking.
Okay, yes. So what's your thinking? Why did you select D?
It's because I feel like when you're going to be stirring in that direction, the particles will also be moving in this like circular movement that would allow the hot particles to go up and the cold ones to come down.
That's more like a vortex, not a convection.
Okay, and
Convection में sir मतलब thermal energy
yes,
would be transmitted.
yeah, you people are allowed to argue with each other. I'm just at a side. I'm observer. Yes, hurry up. Yeah, you people can convince each other. It's an open discussion. I can stop recording. Just a minute. Yes. Now it's your